Alright, welcome to the second lesson. So the first lesson was about multiplying polynomials, and this lesson is about proofs. They're entirely different topics. Eventually you'll have to combine the two concepts, but not yet. So for now, let's talk about a proof. So there's a couple of vocabulary words we need to start with. The first is called a conjecture. So a conjecture is something you think might be true. So a conjecture is something we think might be true. So the example I used in class, I think one of the students is a girl, right? And we're at an all-girls school. But besides that, let's say I'm going to use Sarah. I think Sarah is a girl, right? So that's a conjecture. A theorem is something we know is true because we've proven it. Theorem is something we know is true because it's been proven. Okay, so if I want my conjecture that Sarah is a girl to turn into a theorem, something I know is true because it's been proven, in order to do that, I have to prove it. So that's what a proof is. It's how we turn conjectures into theorems because we're proving a fact. So if I want to turn my conjecture into a theorem, I could say I'm a girl because I have my lady parts and because I identify as a woman. Therefore, it is proven that I am a girl, right? So then that can now be a theorem. However, so the word proof is what we do to turn a conjecture into a theorem. So in general, why do we need to waste time proving things? Because let me tell you, in college, when you're a math major, you start doing things like proving that 2 plus 2 is 4. Very basic things you have to prove is true. And the reason why, first and foremost, is because you should never believe something someone tells you. It's easy to lie, and if you just accept what people believe as truth, then, well, you don't know for sure. And so proving things lets you know for sure that something's true. But beyond that, in higher level mathematics especially, but in the real world too, there are different mathematical universes. And what I mean by a mathematical universe is that you can set up a universe in which only certain rules exist. For example, a different universe in your real world is a clock. Because a clock is different because it only goes forward and it only has 12 numbers on it. So on a clock, 8 plus 5 is 1. Because if it's 8 o'clock, 5 hours later it becomes 1 o'clock. And that's way different than in money. With money, if you have $8 and you add 5 more, now you have 13, not 1. And so depending on the world or mathematical universe you live in and operate under, different things are true. So why do we need to prove things? So we know it's true. In our mathematical universe. Okay? So if we're doing a proof, there's a bunch of things it needs. The first thing you're going to have is all the things you're given. There's going to be certain information given to you. So you need what's given. That's the first thing you need. The second thing you need is what you're trying to prove, right? So the second thing you need is your end goal. The what you're trying to prove. So they start with the facts that they give you, and that's the only facts you can use. And then you're going to use that to try to prove something. And now that you know what you're given and what you're trying to prove, you have to connect the two. And you have to figure out how you're going to take what you're given and make your way through to the end, which is the proof. And so each step that you have for the connect, the given to the end, using, you need both statements and reasons. And this is the important part. Statements and reasons. You always need to tell me what you're doing and why it's true. Okay, so every step in between what you're given and what you're trying to prove, you somehow need to tell me what you're doing between each step and why you know it's true, which is your statement and your reason. So there's 3 types of proofs. There are flowcharts, there's 2-column, and there's paragraph. And these are all of our types of proofs. Okay. So we're going to start with this very real-world example. Let's say you have the following information. You know that ravens are birds, and you know that all birds have feathers. So those are the 2 things you're given. So knowing these things, what's something I could prove? Well, if ravens are birds and all birds have feathers, I could say that ravens have feathers, right? This process where since this is the same as this, I could replace this in here and say since ravens are birds, ravens are part of all birds that have feathers. It's called deductible reasoning. Deductible reasoning is basically the big word for logic. Okay? So knowing these things, what else do I know? I know that ravens have feathers. So that's what I'm going to try to prove. Okay? Here's how a flowchart proof works. A flowchart proof has circles, and in the circles you put the information. So first, what's given to you? I know that ravens are birds. And then I wrote my statement, but I also need my reason. How do I know that? Well, that was given to me. Right? They told me that. The other thing that was given that I know is that all birds have feathers. And that was also given to me. So I write the reason outside of the circle, right underneath it and next to it, and then I write the statement, the thing I'm saying, inside the circle for a flowchart proof. Step 2 is what you're trying to prove, and you write what you're trying to prove at the very bottom. So I'm trying to prove that ravens have feathers. Okay. So from what I'm given, can I say ravens have feathers? Well, yes, I can. So I'm going to take what I'm given and draw an arrow to this box because this is enough information for me to say ravens have feathers because I know that through deductible reasoning. Deductible reasoning. Because deductible reasoning is that logic where you can say, if ravens are birds and birds have feathers, ravens have feathers. And it's just a process called deductible reasoning, which means logic. And we can use that to say this is true. So now I've proven it. I started with what I was given, and what I was given was enough to go straight to the end. Okay? If I want to do this in a 2-column proof, it's just not as picture-like, and it's more 2-column-like, where on one side you write the statement, and then on the other side you write the reason. So the first statement is that ravens have birds, or ravens are birds, and that was given, and that's my reason. The second statement was all birds have feathers. And that was also given to me in my reason column. It gets so much harder to write the more you move down this page. I'm sorry for my bad handwriting. And then, so I had my two given statements, and that's enough to jump to my end that says ravens have feathers. And I know that, and my reason for that was the deductible reasoning. Deductible reasoning. Okay? And finally, in a paragraph proof, you just, instead of going statement, reason, statement, reason, statement, reason, in either a picture or in a table, you write it all out like it's a paragraph. So you start with, instead of saying given, you can say, I know ravens are birds. And I know birds, all birds, have feathers. Therefore, ravens have feathers because of deductible reasoning. I spelled deductible wrong this time. Deductible reasoning. Okay, so note that I still did statement and reason. I know was because it was given, and then for the ravens have feathers, I would said because of deductible reasoning. So even though I'm just writing it all out as a paragraph, I'm still giving the statement and the reason. So let's make this more mathematical. And I'm going to show you each type of proof with this, just like before. But normally I'm going to only ask you to do one. So it starts with saying you're given that a plus b equals 2c, and that b equals c. And you want to prove that a equals c. Well, mathematically, if b equals c, instead of b up here, I could write what it equals. So I could say a plus c, because I'm replacing it here, equals 2c. Then if I subtract the c on both sides, a, c minus c is 0, equals 2c minus c is just 1c. And now I have that a equals c. Okay, so then what did I do mathematically? How do I prove this? Well, I always start with what's given. So one thing is that a plus b is 2c. 2c. And that's given. And remember, I need to write the statement, or the reason underneath the statement. I also know another given is that b equals c. Given. Okay? At the end, I want to prove that a equals c, somehow. I don't know how, I don't know my reason yet, but I'm trying to get there. Well, the first thing I did was, because if I know this and I know this, I was able to say that a then plus c equals 2c. And I did this because I substituted this c in for that b. So I write substitution. So because of this circle and this circle together, and the fact that I substituted it in, I got that. Now, what I did next was I subtracted c from each side, and I found out that a equaled c. And so I figured that out from here to here because of subtraction. So I wrote that I did subtraction. See it from here to here, and now I've proven that a equals c. And it's proved. And then if I wanted to do this in a 2-column proof, remember I have my statement on my left and my reason on my right. My first statement is that a plus b equal 2c, and that was given. Next I had that b equaled c, and that was given. Then I was able to say that a plus c equaled 2c. And I did that through substitution. Wow, I spelled that word very, very, very wrong. Substitution. Alright, and then I minused it over so I could say that A equaled C. I did that through subtraction. And then I got to the thing I wanted to, which was that A equaled C. Finally, if I wanted to do this as a paragraph, I just write out each step like it's a sentence. So I know A plus B equals 2C. I know B equals C. Through substitution, I can say that A plus C equal to C. After subtracting, I find that A equals C. And that is the paragraph proof of this problem.